Hi, my name is Zhang Huanchen. Today I want to introduce the one-dimension barcode and the two-dimension barcode. First, what's the one-dimension barcode? It is the stick consists of black bar and the white space on the chip. How does it work? First, we can save the information of the merchants in the computer. Second, based on the principle of light, we can use the bar machine to read the barcode. The bar machine will launch a red light to the barcode, and the black bar will reflect less light than white one. And when the lights come back to the barcode, we can find the information of the merchants in the computer. As for two-dimension barcode, it can save more information than one dimension can. Different from one dimension, it can save not only English, but also other language. One of the most common two-dimension code in Asia is QR code, and it has 3 entry points for iPhone to read it from any direction. Thanks for listening.
Hello, my name is Wang Dawei. Now I want to introduce barcode machine, which you often see in supermarket or convenience store. Introducing how the application of barcode machine. In fact, barcode machine is a machine to turn the strip of barcode into information with emit light diode. The machine shows a bunch of red light to scan the barcode. The barcode will reflect different light. This way, CCD will get different information from black and white strip and turn it into information. That is the reason why there is a row of red light in front of the barcode machine is used to induce the code.
Hello, 再一次，好，继续开始。RFID phoneme is radio frequency identification, as known as a frequency technology. Is briefly invented in World War II to identify enter the airspace is the friend or foe. Today I want to take a sales car Today I want to take a sales car for an example. RFID usually consists of a reader and a tag. And the tag consists of a coil, an IC chip, and capacitors. And the reader will continue to emit a magnetic field. And when the tag close to the reader, the magnetic field in the coil will change. And according to the Faraday's law, it will induce a electric 怎么办啊？继续吗？It will induce electric.
大家看镜头。
It will induce the electromotive force, and it will accumulate in the ice cap. And and the energy will accumulate in the capacitor, and it will trigger the IC chip, and the IC chip will play a signal consist of 1 and 0 back to the reader. Thank you for your listen.
Hello everybody, now I want to introduce different frequency of the text. Now I want to introduce is super high frequency. The characteristic and application is applied to super high frequency, and it is similar to microwave, and it is more sensitive to environment. It is generally applied to luggage tracking or supply chain management. And then the next, the active and passive are always applied in ultra high frequency. The passive text needs to be read from 3 to 4 meters away, and its flow rate is faster and lower cost. Therefore, it can be read and identify a lot of text at the same time. And because of mainstream in market, like luggage management in airlines, it will be widely used in passengers and luggage management system in airlines and goods delivery management. And then it is high frequency. The main application of high frequency is easy card. Compared to low frequency, it is faster and can read a lot of text at the same time. Its baud rate is faster, and it is applied in easy card, smart card, and library management. And the last is low frequency. The greatest advantage of low frequency is that it can be read when it is close to metal or liquid. On other higher frequency text, it can be reflected from metal and liquid, but it should be read from a short distance and cannot be stored with a lot of information. And it is widely used in animal microchip, and it is widely used in microchip security system.
I'm going to demonstrate our experiment. We use a oscilloscope and a function generator and 2 coils. First, we link the function generator to the purple coil, and it will out a signal of 161 kHz sine wave. So the purple coil will generate a continuously changing magnetic field. Then we put this card to this tube. It will generate induced current. The induced current will drive the IC chip inside the tag, and the tag will send back its signal to this coil. We link this coil to the oscilloscope to read this card signal. We put it on the tube. Okay, you can see the picture. There are many higher parts and lower parts, and the higher parts represent 1. The lower parts represent 0, and you can see the stick parts. It is composed of many 1 or many 0. So that is this tag signal. This is our experiment of simulating RFID reader. I'm going to demonstrate our second experiment. We use a function generator to out a sine wave to this coil. So the coil will generate a continuously changing magnetic field. and then you can see this equipment. It is composed of a coil, a LED light, and a siren. We put it on the tube. And then this equipment is our simulated tag. It is composed of a coil and a capacitor. When we put this tag on the tube, it will receive a magnetic flux and generate an induced current. When the induced current runs through this capacitor, the capacitor will start to store energy, and the capacitor release the current to coil, form a phenomenon called LC oscillation. So this coil can transfer energy to the siren and the LED light. LC oscillation has its own frequency. When the frequency of LC oscillation corresponds to LED light and the siren will sound and LED light will light up. Okay, we put it on the tube. This is our second experiment, simulating RFID tag.